Hello everyone, welcome back to Factoring Quadratics Part 2. In today's video, I'm going to show you how to factor quadratics that don't have the leading coefficient of 1. Alright, so here's the first quadratic we're going to be dealing with. We have 4z squared plus 9z plus 5. Before, when factoring quadratics where the leading coefficient is 1, we would find a set of number that multiplies to the last term and adds up to the second term. However, the leading coefficient in this quadratic is 4, so what we did before is not going to work. Instead, we're going to multiply the coefficient value of the first term with the third term. Then we're going to find the special two numbers that multiply up to that product and add up to the middle value. So 4 times 5 is equal to 20, and 9 is the number that those two values will have to add up to. So the first two numbers for factors of 20 that comes to my mind are 4 and 5. And as you can see, 4 and 5 actually add up to 9 as well. So let's write down the special numbers. 4 times 5 is equal to 20, and 4 plus 5 is equal to 9. Now let's rewrite our expression. We're going to bring down the first term completely, 4z squared, and then split our middle term into two parts, plus 4z and plus 5z, which are the special two numbers, and also we're going to bring down our fourth term completely. Now let's factor out a GCF from each set of two terms. So for our first term, we have 4z as our GCF, and we're going to divide both terms by that value. That leaves us with z plus 1 in our first bracket. For our second two terms, the GCF of 5z and 5 is simply 5, and inside our bracket we're going to have z plus 1 again. Now for our final answer, we're going to have two sets of brackets, one of which has our GCFs together, and the other one has whatever is inside those two brackets, z plus 1. Alright, here we have another quadratic expression. However, the numbers in this quadratic expression are actually quite large, such as 35 and negative 50. When we come across a large question like this, we can check if we can pull any factors out of the entire expression. So a number that I can think of that is divisible by all three of these numbers is 5. So we can pull 5 out of the entire expression. We're going to put 5 outside of a set of parentheses, and we're going to divide each term by 5. So 7x squared minus 10x plus 3. And close off our bracket, and there we have a simpler expression to work with. So from here we basically do the exact same thing as in the last question. However, we do have to remember to bring down the 5 that is being multiplied with everything. Now let's multiply the first coefficient by the last number and we get 21. So our special set of numbers will have to multiply to 21 and add up to negative 10. And because 21 is positive and negative 10 is negative, both of our numbers have to be negatives. And those two numbers are negative 7 and negative 3. So negative 7 times negative 3 is equal to 21, and negative 7 plus negative 3, or negative 7 minus 3, is equal to negative 10. Now let's bring down our expression from our second step. Remember, because we already have a 5 that's factored out, we're going to write down 7x squared minus 7x minus 3x and plus 3. Don't forget your bracket, and let's bring down our 5 again, and let's start finding the GCFs of each of the two sets of terms. So the GCF of 7x squared and negative 7x is 7x, and inside our first bracket we have x minus 1. And the GCF of negative 3x plus 3 is negative 3, and inside our second pair of brackets we have x minus 1 again. Now let's put a big bracket around the entire thing so that we know that 5 is being multiplied into everything. Now for our final answer, we're going to have two sets of brackets again, one of which is 7x minus 3, which is the GCFs that we pulled out, and the other one is x minus 1, which is inside one of the two brackets. And we must not forget the 5 that we factored out of the entire expression. Put a box around that because that is your correct factored form of 35x squared minus 50x plus 15, a quadratic expression where the leading coefficient is not 1. Thank you so much for watching, and I'll see you next time.